This video is titled Rigid Transformations. It is found on the bottom flap of section number 1 of your Unit 7 Similarity Flipbook. This is basically a review video because you've already learned these last year in Integrated Math 1, but I need to go over them with you because they also apply and tie into some of the things we're learning in this unit. So your essential question for this video is, what are the 3 rigid transformations which produce congruent images? And this word isometries, we learned that word last year if you remember it. It just means an isometry is just a rigid transformation or some kind of transformation that takes a pre-image and creates a copy which is congruent to the original pre-image. So it makes a copy of a pre-image which happens to be a congruent image. And there were 3 different rigid transformations that we learned last year. I'm going to move my video over here so we can concentrate on each one of them. The first rigid transformation we learned was translation. Translation. And we also could use just a regular word for that. One of the things I taught my students last year was, this is like a slide. Take any shape and just slide it to a new location. It doesn't change the shape at all, so it still is congruent, but it just moves it or slides it to a different location. So let's go ahead and do an example of this. So let's say our example is, let's say, we're going to slide something. We're going to slide something 6 units right and 2 units down. 6 right and 2 down. So let's go ahead and draw a triangle here. I'm going to go ahead and put some points on the graph for you. Let's say this is point A. Let's make that negative. This is -3. Looks like -3, 5. Then we're going to put a point B here. And let's say this is point B. And that looks like it's -5, 3. I better make that readable so you guys can read it when you're watching. -5, 3. And then let's go ahead and draw another point here. Let's label that as point C. And let's say that looks like that's -2, 3. -2, 3. Okay, and let's go ahead and connect these. I'll try to connect those. Let's connect them with a red. I'll do my best to draw straight lines here. So there's our original triangle. Remember, we called the original shape the pre-image. So I'm going to go ahead and put just PI here for pre-image. That's our starting shape. Now we're going to go ahead and figure out what happens to that shape when we translate it 6 units right and 2 units down. Well, this is actually pretty easy to do. We're going to go ahead and take our point here A and go 1, 2, 3, 4, 5, 6. To the right and 1, 2 down, and there's going to be our new point A. And then we're going to take our point B, 1, 2, 3, 4, 5, 6, 1, 2, and point C, 1, 2, 3, 4, 5, 6, 1, 2, and there are our new points. Let's go ahead and connect those again with red lines, red segments. And let's go ahead and write down what those new coordinates are. So now A is going to be, looks like that is, so I'm going to call that A prime. Talk about that in a moment. This is going to be 3, 3. And we've got our new value of B, which looks like it's 1, 1. And our, that's B prime. And then our new value of C, which is C prime, is at 4, 1. Now remember, class, if this is the pre-image, then this triangle is called our image. That's our copy of our original triangle. So pre-image is our starting image, our starting shape, image is the copy of that. So pre-image and image. Okay, now we learned something else last year, and that's called transformation notation. So if you look at this example of sliding this pre-image 6 units to the right and 2 units down, you can actually write this in transformation notation. If we take the original coordinate x comma y, we translate it to x plus 7. There's our movement 6 units right. And then y is going to have 2 subtracted to it, that 2 subtracted from it, that's our 2 units down. So we can actually use transformation notation to find these points. So if this was not on a graph, if all you had were these coordinates, you could find the new coordinates by using this transformation notation. Let's do that. A, which used to be at -3, 5 in our pre-image, now is going to become a prime, and we'll just take a -3 plus 6 is positive 3. 5 minus 2 is positive 3. And you can see we can get a prime this way as well. Let me fix that 3. So another way of doing it, let's go ahead and go through this and just do b. Our b value was originally at -5, 3. Now we're going to translate that through our transformation, and now it's going to be b prime, which is -5 plus 6 is 1, 3 minus 2 is 1. There is our new b coordinate. And let's go ahead and do c. c used to be at -2, 3. We're going to translate that through our transformation notation, and we're going to do with c prime, which is equal to -2 plus 6 is 4. 3 minus 2 is 1. So you can see we can get these 3 points by using transformation notation as well as by just counting units and moving it on the graph. Okay, so you're going to write somewhere in your notes here, you should write in the margin transformation notation. We'll do a little bit more of this later on in the flip book. Transformation notation. All right, there's our translation. Let's go ahead and do the next one. The next one was reflection. So our next isometry was reflection. And we also called this something different in my class. We also said reflection is kind of like a flip. Reflection flips a shape over. Let's do an example of that. How about if we do an example, let's flip across, let's fix that. Let's flip across the y-axis. So flip across the y-axis. So let's start off with our original triangle here. I'm going to pick a point here. Let's say here's 2, 2. Let's go up to here and go down to here. Here's an example triangle. Let's go ahead and connect those points together. And we'll label these. So it's going to be A, which is, looks like it's at 3, 4, and B looks like it's at 2, 2, and C is at 5, 2. Now, in order to reflect or flip this across the y-axis, we can also use transformation notation. This is the transformation notation for a flip across the y-axis. The x value, original x value, just changes to the opposite sign, and the y value stays the same. Let's go ahead and run our points through this transformation notation and figure out where our new triangle goes. So A used to be at 3, 4. Now, the 3 is going to change sign. It's going to be -3, and our y value doesn't change at all. Let's go ahead and do B. B was at 2, 2. Now it's going to be at -2, 2. And sorry, I should be writing here, this is A prime, and this is B prime. C, which used to be at 5, 2, now is going to end up at C prime, which is 5 change it to negative, so negative 5, comma 2. And remember, prime notation is just a way of saying, hey, it started off as A in our pre-image, now it's in our image or our copy, and we just use prime because we can't use the same letter or we're not going to know which point we're talking about. Let's go ahead and graph this new triangle. So now let's pick another color here. So I've got A prime is now negative 3, 4. Negative 3, 1, 2, 3, 4. B is now negative 2, 2. C is now C prime, which is negative 5, 2. There's our new triangle. Let's go ahead and connect those points together. You can see now that this triangle has been flipped to the other side of the y-axis. And we can go ahead and label our points. All I'm going to do is label them as A prime, B prime, and C prime. We won't write the coordinates just to save a little bit of time. So there's our new points. Based on flipping or reflecting our original triangle, let's go ahead and label this as pre-image across the y-axis to form a new congruent image. Last one. See, if you remember this, the last transformation we learned last year was rotation. This one is the one that gives most students trouble. And this is called a turn. It's like turning a shape, clockwise or counterclockwise. Let's do an example of this. Our example could be, let's turn 90 degrees clockwise. And remember, clockwise is going the way a clock turns, so it's this way. Going around the circle like that. Alright, let's go ahead and graph our original triangle. I'm going to put one at, let's see, let's make a point here, and here, and here. So here is our original triangle. Now I'm going to tell you, rotating just by looking at it is much more difficult than translating or reflecting. So we're going to use transformation notation for this. Let's write our original points. This is, let's get this in blue, this is A, which looks like we're at negative 3, 6. B is at negative 5, 4. And C looks like it's at negative 2, 4. Negative 2, 4. All right, here is transformation notation for a 90-degree clockwise rotation. So all we got to do is plug in our original points, and we'll come out with our new points. Our A value was first at negative 3, 6. By the way, that's our pre-image. And now what's going to happen is, take a look, for A prime, the x value moves over to the y value and changes to negative. So negative 3 changes to positive 3 and goes here. The y value was 6. It moves to the x position and the sign stays the same. There's our new A prime. Let's go ahead and do B. B was negative 5, 4. That means B prime is going to be 4. There's our y value, and now x is going to move to the y position but change sign, so 4, 5. And then our c value, which was negative 2, 4, is now going to change to c prime. The y value, or the x value, moves to the y position and changes sign. The y value moves to the x position and stays the same. There's our new points for our rotation. Let's go ahead and plot those. We've got 6, 3, 1, 2, 3, 4, 5, 6, 1, 2, 3. There is A prime. B prime is 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's B prime. And C prime is 4, 2. 1, 2, 3, 4, 1, 2. There is C prime. And now we can go ahead and connect those together. And there is our rotated triangle, 90-degree clockwise rotation. Now, of course, we can rotate counterclockwise. We can rotate 180 degrees. And remember one more thing. This is a rotation around the origin. So we're rotating around point 0, 0. There is a review of the 3 transformations we learned last year.